Hello, wonderful staff of the greatest dialysis unit in the history of the dialysis world, the Kent Northwest Kidney Center. Today, we will discuss a fun topic called xenotransplantation. That is, transplantation of organs from animals to humans. I chose this topic because of the recent medical breakthrough in which a pig heart was successfully transplanted into a human earlier this month. This is a major accomplishment which opens doors to significant changes in how we will likely treat organ failure in the future. It may eventually put this and other dialysis units out of business, which is a wonderful thing for our patients. Of course, don't worry because we will always need dialysis units, and it will take many years for all this to happen, so no need to look for a different occupation at this time. Objectives to today's talk. Appreciate the current organ shortage. Be familiar with the history of xenotransplantation, understand the barriers to xenotransplantation, and recognize recent accomplishments in overcoming these barriers. As you all know, mortality on dialysis is high, and the quality of life on dialysis is often low. Transplantation offers at least twice the longevity and a much better quality of life, which is why we work so hard to achieve this for our patients. But of course, organs are scarce, and most patients on dialysis die without ever receiving a kidney transplant. There are more patients awaiting a transplant than available organs, and the waiting list grows every year. In 2021, some 41,354 Americans received a transplanted organ. More than half of them received kidney transplants. This is according to the United Network of Organ Sharing, which is a nonprofit that coordinates the nation's organ procurement efforts. But there's an acute shortage of organs, and about a dozen people on the list die each day while waiting for an organ, and there are currently 100,000 Americans on the transplant list, including 90,000 who need a kidney. So where do kidney transplants come from? Well, about a third of organs for kidney transplantation come from living donors. And about 2/3 come from donors who have passed away. And of course, this is insufficient to meet demand, which leads to long waiting list times. The average waiting list time in the Pacific Northwest is about 4 years, which is remarkably short. In most other parts of the country, for example, California, in the South, East Coast, the waiting list can be up to 10 years. Now, one potential solution to this problem is transplantation of animal organs into humans, so-called xenotransplantation. Okay, so what is xenotransplantation? Xenotransplantation is the transplantation of tissue or organs from an individual of one species transplanted into or grafted onto an organism of another species, genus, or family. A common example of this is use of pig valves, which you've been using for over 30 years to replace failing human heart valves. Xenotransplantation has long been appealing as a possible solution for organ shortage. So the advantages of xenotransplantation, particularly if we could use a readily available animal source such as a pig, are numerous. So first, there would be an unlimited supply of donor organs, which would resolve the current severe shortage of human organs. Essentially, we have available to us currently genetically engineered pigs, which are sort of viewed as a potentially sustainable, renewable source of organs, sort of like solar and wind in the energy world. Second, organs could be available on demand. So currently, a patient may wait several months in an intensive care unit with an artificial heart while awaiting for a heart transplant, or, as you all know, several years on chronic dialysis while awaiting a kidney transplant. But if transplantation could be carried out as soon as the patient experiences irreversible organ failure, then immediate transplantation would almost certainly result in significantly improved survival. Third, and this point is often overlooked, but brain death. So when a patient, say, is in a car accident and their brain dies, but their organ is still being perfused, the heart's still pumping. Brain death itself has numerous adverse effects on donor organs, particularly the heart, that can lead to either primary graft non-function or other injury. But in the case of xenotransplantation, say of pig organs, this would be avoided as organs would be excised from a healthy pig under anesthesia. Fourth, the risk of a novel infection would be lower. So almost no year passes without a novel microorganism being transferred from a donor to a recipient with a graft. So for example, in recent years, West Nile virus, rabies, HIV, and other microorganisms have been transferred to donors with fatal results. And while there's been some concern that a porcine or a pig microorganism might be transferred with a pig organ, the pig herd used for transplantation would be housed under ideal conditions and be monitored at regular intervals for infectious agents, providing a much greater chance that the donor animal would be free of all known pathogenic organisms than, say, compared to an average deceased human donor. We wouldn't need living donors anymore. The surgery itself is not without risk. There have been living donors who have died in the process of donation, and to not have to subject a healthy patient to a risk in the process of transplantation would be a wonderful thing. And potentially, xenotransplantation could overcome cultural barriers from receiving a kidney from someone who has died. Some cultures feel uncomfortable with this. That said, of course, I understand that using a pig organ may not necessarily be accepted by some religious groups, such as people of Jewish or Muslim faith. So the rules of xenotransplantation would need to be addressed by these groups. So what is the ideal animal donor in xenotransplantation? Well, many animals have been used. Baboons, chimpanzees, pigs, etc. But pigs offer several advantages. First, there is unlimited availability of pigs. We are very good in this country at raising pigs. They've got excellent breeding potential. The typical length of pregnancy is just under 4 months. The typical number of offspring is 5 to 12. They rapidly grow to adult size within 6 months. Their organ size is actually pretty similar to human organ size. There is a fairly low cost of maintenance of pigs compared to, say, baboons or chimpanzees. There is moderately close anatomic similarity to humans. The heart, for example, looks like a human heart, and the kidneys look like human kidneys. And finally, there's a lower risk of transfer infection. We talked about being able to raise pigs in a sterile, basically medical environment. And there's also favorable public opinion. Most people are okay with using pig organs. People have more, I think, emotional attachment to baboons, chimpanzees, and other primates. Xenotransplantation has a long and storied history. The concept of xenotransplantation or cross-species transplantation is actually centuries old. In ancient mythology, there are many examples of mythical humans with hybrid animal bodies. So, for example, Lamassu is a celestial being from ancient Mesopotamia, bearing a human head, a bull's body, sometimes with horns, ears of a bull, sometimes with wings, and it frequently appears in Mesopotamian art. Most of you are familiar with the centaur from Greek mythology, with the upper body of a human and lower body and legs of a horse. In Egyptian culture, the Sphinx is a mythical creature with the head of a human, the body of a lion, and wings of a falcon. And in Hindu religion, Ganesha is a well-known Hindu god of many things, including good luck. I believe he's a patron of arts and sciences and intellect and wisdom. And at one point, he was human, and then someone cut off his head and then replaced it with that of an elephant. So this would be the first documented head transplant. In medicine, the idea behind xenotransplantation dates back to 1667 when the French doctor Jean-Baptiste Denys tapped the veins of farm animals to perform human blood transfusions. So his first patient was a 15-year-old boy who miraculously survived the procedure, likely due to the small amount of sheep blood that he received and allowed him to withstand the allergic reaction. The subsequent two patients, not so fortunate, they both died. And thereafter, the procedure was banned. It did not receive public approbation. Now, the first widespread attempts at xenotransplantation occurred in the 19th century with skin grafting. Surgeons used many species as donors. Rabbits, dogs, pigeons. Turns out that frog skin was most popular. They were undeterred by the presence of fur or feathers when grafting skin. And there were claims of miraculous cures, although most historians believe that none of the grafts likely became permanent. Rather, they were probably effective in just covering a wound and allowing, or basically serving as a protection for the ulcer underneath while the patient's own skin formed below it. Remarkably, in 1838, the first corneal xenotransplantation from a pig was performed. And this is actually long before the first corneal allograft. So the human corneal transplant was carried out in 1905. And corneal transplants have since been done with corneas from pigs, sheep, dogs, rabbits, gibbons, cows, and even fish. The field of xenotransplantation was propelled forward in 1954 with the first successful kidney allotransplant, so the transplant from human to human. So Joseph Murray and his colleagues at Brigham Hospital in Boston successfully transplanted a kidney between two identical twin brothers. The transplant in part was a large success because there was no immunologic barrier between the identical twins. Of course, they have the same immune system. Now, the immunologic barrier is particularly large in xenotransplantation because different species have so many different proteins. But the idea that a transplant could successfully be performed gave impetus to the xenotransplant movement. In the 1960s, the limited availability of donor organs again raised interest in animal sources of organs. There was a professor at Tulane, Louisiana, named Keith Reemsman, so he's a surgeon, and he hypothesized that primate kidneys could function in human recipients. And he selected chimpanzee as a potential donor, again, close evolutionary relationship between humans. So Reemsman carried out 13 chimpanzee to human kidney transplants between 1963 and 1964. Unfortunately, the outcome was not good. 12 of them died within weeks of surgery because of either hyperacute rejection or infection. Interestingly, however, there was one patient who survived for 9 months. She actually returned to work as a school teacher and apparently remained in good health until one day she suddenly collapsed and died. And an autopsy was performed. No cause of death was determined, but it appeared that the chimpanzee kidney was still functioning normally without evidence of rejection. Also in the 1960s, other physicians, for example, Thomas Starzl, performed liver transplants between chimpanzees in numerous young patients, but unfortunately the outcome was not good. The first chimpanzee liver transplants were done in children between 1969 and 1974, but none of them survived more than 2 weeks. And between 1968 and 2012, several pig to chimpanzee liver transplants were performed, but survival was always brief, typically around 1 week. In 1964, James Hardy, a physician at the University of Mississippi, carried out the first clinical heart transplantation and decided to use chimpanzees as donors in the event that he couldn't identify a deceased human donor. He had a really sick patient, really bad vascular disease. He had bilateral amputations. He was semi-comatose at the time of surgery, and Hardy transplanted into him a chimpanzee heart. Unfortunately, the heart didn't prove to be large enough to support the circulation, and the patient died within a couple of hours. Public and medical professional response to the heart xenotransplantation was not favorable, and further attempts were discouraged by the court of public opinion. But desperate times, desperate measures. Perhaps the best known cardiac xenotransplant since then was performed by Leonard Bailey, who transplanted a baboon heart into an infant girl known as baby Faye. And that was in 1983. And at that time, it was also almost impossible to find human organs from infants that you could transplant into recipient infants. The surgical procedure was technically successful, but again, not surprisingly, the graft underwent acute rejection and the baby died 20 days later. Now, in the 1980s, a pioneering heart transplant surgeon by the name of David Cooper, who's still practicing, he's now at the University of Alabama, he began to argue that monkeys are not the best donors for human. His most important argument was the size of the organs. He thought that the heart of a monkey is simply not big enough to support a human adult, while pigs, on the other hand, could be a more suitable alternative. They have bigger hearts that could meet the circulatory needs of humans. But even with the optimal animal donor size, there were technical barriers that made xenotransplantation difficult, and these are rejection and infection. So now we're going to talk about barriers to xenotransplantation. So transplant rejection occurs when a transplanted organ or tissue is rejected by the recipient's immune system. White blood cells, which normally fight infection, recognize foreign proteins and attack them, which destroys an organ. To minimize this risk, we give our patients immunosuppression or medications that suppress the immune system. But even with modern immunosuppression, we are unable to prevent rejection of many foreign proteins, particularly from non-human donors, and the risk of excessive immunosuppression is the development of an infectious complication. So, how has science dealt with the problem of rejection in xenotransplantation? The most powerful tool we have now to dealing with rejection is gene editing and cloning. In the 1990s, the Cooper lab, so Cooper again is the heart transplant surgeon at the University of Alabama, he identified the sugar alpha-1,3-galactose on the surface of porcine cells or pig cells as the main trigger for the human immune system. So it's expressed on the pig's vascular endothelium, so the lining of the blood vessels, and it's absent in humans, who then generate an anti-gal antibody leading to hyperacute rejection within minutes to hours. So the problem was overcome by the development of pigs who were homozygous for lacking this sugar. So basically, they got rid of the gene that encodes the sugar on the vascular endothelium, and so you have these knockout pigs that no longer express that sugar on the vascular cell surface. Additional genetic modifications have been made among transgenic pigs. Most have focused on removing additional proteins from the surfaces of pig cells that are not present on humans, and they're designed to prevent various forms of rejection, including hyperacute rejection, delayed xenograft rejection, acute cellular rejection, and chronic rejection. Another modification prevents the heart and other organs from responding to growth hormones in the recipient, ensuring that the organs from, say, the 400 kilogram animals remain human size. Infection is also a potential barrier to xenotransplantation. With the COVID-19 pandemic, the FDA is very concerned about ensuring that xenotransplantation will prove to be safe from the perspective of, say, potentially transferring porcine microorganisms with a graft to the recipient and maybe even to the general population. In fact, they were so concerned about it that in 1997, there was actually a worldwide ban or moratorium on animal to human transplants. One major concern has been the transmission of a virus known as the pig endogenous retrovirus, or PERV, into the human population. So the pig or porcine endogenous retrovirus, or PERV, these are retroviruses that have infected the germ cells of pigs, so the sperm and the eggs, leading to integration of the DNA basically into the DNA of the pig. So basically every cell in the body of the pig contains these retroviruses. So if you transplant a pig organ that contains PERV, there's potential that that would infect a human, and this could potentially spread beyond the transplant population to the general population. Amazingly, in August of 2017, researchers from the George Church and Luhan Yang lab at Harvard announced a breakthrough in xenotransplantation. Basically, they had used this CRISPR gene editing technique to inactivate 62 PERV genes in the pig cells. And from these fetal cells, they cloned embryos, and out of the 37 piglets that were born, none showed any trace of this PERV virus. And if that gets employed in xenotransplantation, this would eradicate the risk of viral transmission to humans. Other infections could potentially be transmitted through xenotransplantation, but most porcine viruses, bacteria, fungi can be eliminated by the selection of negative donor animals, particularly if you breed them in sterile and isolated conditions. So pigs, of course, they are used for transplant, will have to be housed under very strict conditions that are routinely screened for pathogenic microorganisms. In that sense, because these pigs have been raised in essentially a really clean and monitored environment, they could actually be safer from an infection standpoint than an allograft, say, from a recently brain-dead human, where maybe there has been insufficient time to screen for all the potential infectious agents. So all of this has basically been an introduction or a background to a watershed event that happened earlier this month on January 7th, 2022. Basically, it was the first ever successful transplantation of a genetically modified pig heart into a human. So the first pig-to-human heart transplant. It was an 8-hour operation. It took place in Baltimore, as I said, on Friday, January 7, 2022. The recipient was a 57-year-old man named David Bennett. And essentially, doctors were granted a special dispensation by the U.S. medical regulator to carry out the procedure on the basis that the patient would otherwise have died. So the researchers had applied to the U.S. FDA to do a clinical trial of pig hearts in people, but were turned down. The agency was concerned about ensuring that the pigs came from medical grade facilities and wanted the researchers to transplant the hearts into 10 baboons before moving on to people. But Bennett had been on cardiac life support for almost 2 months. He couldn't receive a mechanical heart pump because of an irregular heartbeat, and he couldn't get a human heart transplant because he had a history of not complying with doctor's treatment instructions. So given the certainty of death, the researchers basically got special emergency permission to give Bennett a pig heart. The surgery was conducted at the University of Maryland School of Medicine at the University of Maryland Medical Center, and so far the patient is still doing well 2 weeks out from his surgery. 3 months prior to this, in October 2021, surgeons at New York University Langone Health transplanted kidneys from the same line of genetically modified pigs into 2 legally dead people with no discernible brain function. The organs were not rejected and functioned normally while the deceased recipients were sustained on the ventilator. The kidneys were not actually put inside the human, but were attached to the body of the recipients. Just today, there was a case report published of the first pig-to-human transplant in a brain-dead donor in which the kidneys were actually internalized into the donor. His native kidneys were removed, and then 2 pig kidneys were implanted at the pelvis, the usual location for a transplant. And both xenografts produced urine, and there was no evidence of rejection or infection. The patient did die about 3 days later from multi-organ failure related to his brain death. Needless to say, these pig-to-human kidney transplants and pig-to-human heart transplant have the potential to completely eliminate the transplant waiting time and to minimize or potentially avoid the need for dialysis in patients with kidney failure. So this would be a great reason to put all dialysis centers out of business. So, these recent developments in pig organ transplantation are proof of principle that xenotransplantation is an option for humans and basically can usher in a new era of transplant medicine where replacement organs are no longer in short supply, and the more than 500,000 Americans who are waiting for kidneys and other organs can receive them in a timely fashion. Now, pharmaceutical companies recognize this. Among others, Novartis plans to spend more than $1 billion for a scientific research and infrastructure facility where pigs can be raised in a germ-free environment around the world. There's some British companies such as the Boston-based Genzyme and PPL Therapeutics, the ones who are involved in the creation of Dolly the sheep, the first cloned animal, are also involved. But for now, there's only one company, Revivicor in Blacksburg, Virginia, that's owned by United Therapeutics that has suitable facilities and clinical grade pigs. And these pigs are being raised at a facility near Birmingham, Alabama, although they're building a larger facility in Virginia that could potentially supply hundreds of organs per year. Time for your favorite part of the talk, the monthly quiz. All right, the first question is a very easy one. What is xenotransplantation? Excellent. Transplantation of tissue or organs from an individual of one species into or grafted onto an organism of another species, genus, or family. Question number 2. Name 3 advantages of xenotransplantation over what we're currently doing, which is allotransplantation. Excellent. Unlimited supply of donor organs. Organs could be available on demand. You avoid the deleterious effects of brain death on organ function. The risk of novel infection is lower. You don't need living donors anymore. And there's potential to overcome culture barriers of receiving a kidney from someone who has died. Question number 3, why are pigs potentially optimal animal donors for xenotransplantation? Many reasons. Unlimited availability of pigs in this country, good breeding potential, short duration of pregnancy, lots of babies, rapid growth to human size within 6 months, adequate organ size, lower cost of maintenance of pigs compared to other animals such as baboons or chimpanzees, close anatomical relationship to humans, lower risk of transfer and infection, and favorable public opinion. Question number 4, what are the main barriers to xenotransplantation? Excellent. So the two main barriers are infection and rejection. Last question. Why was a recent pig-to-human heart transplant such a major breakthrough for transplantation? Excellent. So it's the first ever successful transplantation of a genetically modified pig heart into a human. Opens the door to much more in the future. So I'm so excited about the possibility of this becoming a routine for our dialysis patients. It would be amazing if we could get rid of the transplant waiting list. Thank you so much for your attention and much more for the wonderful service that you provide our patients at the Kent Dialysis Unit. I appreciate everything that you do. This is Andy Brokenbrough signing off until next month.